Good afternoon, everybody. How are you guys going? Yeah, a bit of energy, eh? The conference is kind of winding up a bit, so hopefully we'll do a nice presentation and you go home with something interesting. So my name is Stefano. I'm here with Leo. We work in a company called Siteminder, and we are from Australia. So we've flown all the way here to just be at the conference. So what we're going to talk to you about is not something directly related with our day-to-day job. It's a little project that we've worked on together. It's kind of an admin interface for a little IoT application. The main focus of what we want to talk about today is searching. Searching is a common requirement for online application. It's one of those requirements that kind of usually gives me a bit of a headache when product people come and say, can we search by this? Can we search by that? I always try to say, well, that's complicated. That's my first answer. Try and get away from the problem. It's complicated from a back-end perspective, but it's quite complicated from a front-end as well. Now, let's look at it. This is a bit of an outdated example, right? So the moment you want to offer some sort of advanced search to a user, what happens is that you end up having these kind of interesting interfaces which are all but user-friendly. Now, over time, things are going to be better, right? You can come up with something a little bit nicer. The nicest I've found is this one. I won't tell you where it comes from, but you may guess that. It's still a bit complicated for my liking. So if you look at the top, for example, you got a DSL. You can actually enter a title, this or that. You can actually restrict your search by the people, jobs, etc., and you have other filters on the right. So searching is not an easy problem to solve when it comes to building a search UI. Now, when we started working on this project, we had this problem of being able to search across potentially millions of devices, and we were looking for inspiration. So let's see in the room if anybody has an idea of a company or a search bar that has become really, really successful. People are laughing, but you're not telling me. What is it? All right, it's Google, right? So we know it. The reason why Google has been successful, and there's a million reasons, but let's start from the fact that obviously their algorithms work. But another element that I think is actually really was capital, especially at the beginning, was that their search interface was extremely simple. So everybody was able to use it. The difference, though, with our kind of application and what Google does is that we, like in 90% of cases, we actually do deal with structured content as opposed to unstructured content. So it's actually very easy to say, well, just give me a keyword, I'll get you something. Well, it's not that easy, but let's say it's easy to build a UI for it. Just give me a keyword, I'll get something interesting for you. But when you have structured data, you have data that has got values across multiple dimensions. And these are just examples. For example, e-commerce, space, price, color, etc. Now, is search that important? Yes, it is. It is actually very important because if you think about the examples you see here, these are very, very common requirements from a product perspective. You want to know what's the newest shoes, you want to know what's on sale, etc. All right? But even if you go more into different areas like monitoring, if you have devices in the field, you want to know which devices have got issues and particular values for some fields. Now, search and UX. Do you all know what UX stands for? Yes, you do? Right. So UX stands for user experience. Now, it's a very interesting term. It means everything and nothing, really. It has to do with UI, but it is not just the UI. It's how the user uses your system, effectively. There's lots of principles when you're thinking about building any sort of user interface or even a backend. Let's just remember that backends and user interfaces go together. Obviously, a million principles. There's not an exact science. When we started this project, we decided to focus on three elements. Adding value to the user and removing everything else. So if you think about the Google search bar, that's exactly that. It's a minimalistic by definition, and that's the only thing that is really interesting. It's in the middle of the page. Ease of access to your content, okay? I know this is going to sound a little bit, I'm kind of wishy-washy, but when you see it in action, you understand where I'm coming from. Free clicks rule has been around for a while. It's a bit of a myth. It's been debunked, but it's a source of inspiration anyway. If your content is too hard to reach, then people won't reach it. They won't find it. And speed. I'm a big fan of speed. That's why I like Redis. Okay, I'll get to Redis. Don't worry, guys. But I like speed because usually when you build a system or any sort of IT, web interface, speed is the last thought. Is this magic thing that will come after you optimize things, and it never comes really in the end of the day. But it does have a huge impact on how the user experience. Okay, so let's see, how fast is fast enough though? If you guys have been at a keynote today and yesterday, there's always this magic number of milliseconds that come up, obviously from a CEO of Redis Labs. So let's see, what do you guys say that it's fast enough in milliseconds? 1 millisecond. No, sub-millisecond. That was what I wanted to hear. So luckily, we don't have to guess. Some people have done some studies around it, okay? So I won't quote the whole studies here, but I put this together based off 2 major studies that I found on the internet. One was from 1993, it was a psychologist in the US, and another one was 2013 from Akamai, the CDN provider. So the 1993 one actually focuses on the lower end of the scale, and the Akamai one is on the higher end. So what happens is, when they did the study, this was quite interesting because the numbers were slightly different, but in 1993, when the system was responding faster than 100 milliseconds, people were saying, well, it feels like it's not actually working. Now, I've moved that to 50 because I really think it's changed. Obviously, we all have mobile devices. We have interfaces. And obviously, in 1993, it was taking, what, 30 sometimes minutes to actually start your computer. So people had different expectations. Anyway, the idea is, on that side of things, there's even a too fast. I don't believe that this actually exists as much, but as part of a study. On the other side, Akamai did a study around people to see when you actually, when you're slow, what happens. And they realized that with anything between 2 to 2.5 seconds, you kind of lose the user. The reason why they did the study is because they want to prove that you need to use a CDN to serve your content faster. But it was quite interesting. If you look at this, you'll see that your sweet spot is not that big, really, because you have to consider latency, you have to consider your application time, and you have to consider your database time. Of course, Redis is sub-milliseconds, so that helps, of course. So let's recap for a second what I talked about. So searching is important. The experience while doing search is important. When dealing with structured data, we want to make search easy and we want to make it fast. Now, how do we make it easy? Is there any pattern that you guys can think of that makes search easy in general? I don't know, mobile devices. Starts with A. Autocomplete, fantastic. Yes, so interestingly, Autocomplete has been invented at Google. It was a side project in 2009. I was reading about it, it's quite interesting. So Autocomplete is a really good pattern because everybody understands it. It works really well on mobile devices where people don't have huge keyboards and it's kind of very much constrained, right? Has any of you guys ever done an autocomplete, implemented an autocomplete for an application? Let's do a raise of hands who's done it. Okay. All right, everybody's done autocomplete. All right, cool. What was your experience with it? Was it easy? Was it hard? It sucks a little bit, right? And even actually commercial software out there, when you start doing autocomplete, you will see response times are really high. It really annoys me. So you may guess that we actually are talking about autocomplete in a second. One hidden gem into the RediSearch module that Dvir, the guy from Redis Lab, just put together so nicely is actually a autocomplete suggestion dictionary support. Okay, so there's a series of functions that support that inside the RediSearch module. So it's something a little bit not as known as the full text index component, but it is as useful. enough for me talking. Let's do a demo, all right? And then I explain a little bit what are the underlying functionalities and how we implement it. So I'm just handing it over to Leo, and we do a quick demo.
Okay, let's see what we've built. Okay, the idea is to support potentially millions of devices and easy to search in IoT space. So this is the UI we built. So in the device page, it's quite simple. It's just a search bar, and underneath is just a table. And in the table, there's some columns: device ID, locality, console, state, country, etc., etc. So as a normal user, when you come in, the only thing they can do is search. So when the user starts search, the autocomplete pops up. It is the common search across the users, or the most common items you can search. Let's try Australia. Boom. Yeah, you get the result instant. And how about we try to search something else, like lake. Okay, I got all the lakes in console, in the locality. Let's see Forest Lake. Okay, cool. And what if I search something like device ID? As you can see, the device ID always ends up something different, but starts 000. Okay, let's see. Let's try end with 90. Okay, that's the device ID we can search. And that's it. We nailed it. Cool. That's pretty much it. Thank you. Let's hand it.
It's actually a quick. It's actually just a quick demo because it's kind of harder to follow what I'm about to describe if you haven't seen what we actually done. So let's see how it works under the hood, like an autocomplete dictionary. Okay, I promise this is the most boring slide, okay? So bear with me for a second. I like data structures, that's why I like Redis. But the idea is that an autocomplete dictionary is actually based off a trie, and more specifically a radix tree. A radix tree is just a compression data structure, really. So it's quite interesting because if you look at this example from Wikipedia, you see that the R is only repeated once in the data structure, whereas in the if you look at the words, there's a lot of repetition, right? So by definition, you will achieve a level of compression rate, but it also allows you to do queries on prefixes, okay? So you can say, well, what starts with R? What starts with ROM, etc. And you just isolated the subtree based off that. So what are the basics? So I'm going to drive you through some examples. But the idea is, if you have an entity, for example, devices, and each entity has got multiple fields. In this case, you got device ID, country status. I think we were supporting 5 or 6 of them, but just to simplify life. If we then ingest every possible value in, so we create a dictionary for each entity and a field name, and we ingest every possible value in each dictionary, like this. What happened is, so in this example, we're only ingesting Australia and United States. What we can do then is that we can do autocomplete queries. So we can say, please return anything that starts with AU or with U, and we get a response. Obviously, the response time is actually quite fast, but one of the key elements that I forgot actually to discuss is your response time is actually most likely big O of 1, so it's constant time. It doesn't matter how many items are in there. Now, it's technically big O of n, where n is the size of your string, but if you think about it, it's not that in English there's words of thousands of characters, right? So you're kind of bound. So you can now query this. We do have a problem though. By doing these kind of queries, we can only do autocomplete on prefixes and not on endings. Now, if you've seen the example before with the device ID, it'll become clear what I'm about to say. So if you're searching for UN, you get United States, and that's fine. But if you search for states, you get no result. Now, you can live with that. But when you get to device ID, for example, device IDs, like this are not uncommon because if they are hardware generated, they will all have a start with the same prefix. So for the user, searching by typing a gazillion zeros is not a great idea, right? Users identify the devices by their ending. So yes, it is a problem. So how do we work around this problem? What is the solution really? It's one of those nice geeky solutions that comes with algorithms. So we ingest every field and every possible values twice. Okay, once as is and once inverted. So if you look Australia and then the inverted of Australia, the device ID, and then it's inverted. So we're doubling. We are effectively doubling our data structures in memory. Now, we can now query against all available dictionaries. So when we get a query coming in for AU, like Leo was showing before, you start typing something. We just do a query against all possible dictionaries, the normal dictionaries and the inverted ones. Okay? So in this case, the user typed AU, and you got three queries that get no results and one that get a result. As we're using pipelining, and if you guys are not familiar with pipelining, when you use Redis, just look it up because it's really cool. What you do is that even though we are running a lot of queries, because we are pipelining them, the performance penalty that comes with running a lot of queries in one go is actually very, very limited. Let's look at another example, a little bit more complicated. So if the user has typed 7EC, most likely, obviously with that, we kind of those letters, the user was actually looking for a device ID, okay? By the way, there's no need to take photos. I'll try and put these online, so hopefully it'll be available. So what happened is that the first three queries will return no results as expected, but the fourth one will match. And the reason is, if you look at it, we are also doing something cheeky here. We are inverting our search key, and we are getting an inverted result as well, but then we flip it again. So this is an interesting way to build to query on endings once you only have a radix tree, effectively. Now, one thing is, when we started this exercise, obviously we started playing with RediSearch. We say, cool. One of the ideas we had was, why don't we actually just use the full-text search? Now, full-text search is really good for unstructured data, as I was covering before, and structured data has got dimensions, so that's not great. But for a moment, I actually thought that we could actually ingest the whole entity, all the entities as JSON blobs, and do a full-text search on them. Now, we definitely can do that. It's not great from a memory perspective, because the full-text search index is never going to be memory savvy. I mean, by its own definition, it's quite uses quite a bit of memory. We do lose the opportunity to query on prefixes and endings, and we also lose the concept of dimension. So we become exactly like Google. So you can't really suggest queries across different dimensions. Now, we've seen this feature. This feature was, if a user entered no text, it would be great if we could show the user something. Again, if you go back to the principle of adding value to the user, sometimes, and this is an interesting thing, searches tend to be repeated. So people search for the same things. You can actually then show the most common queries. They could be across the board, they could be per user, they could be the most common queries within some time interval. Now, implementing the most common with Redis as a trivial algorithm, you can find it on redis.io. And it uses lists, for example. So if we do a search and we identify each search as a key value pair, and we just JSON encode it, and we then remove it from the list, add it on top, and then trim the list. This algorithm is particularly simple, and it feels a bit weird the first time. I can see the faces, but it feels a bit weird the first time you see it, but it's guaranteed to actually work under concurrency. Okay, so it doesn't even require. It does not even require that that these operations run in a transaction. It's quite neat. I think Salvatore came out with this. And it's quite nice. So it's guaranteed that it's also bound in terms of the size and the speed. So to sum it up a little bit, search is a very common requirement for online applications. UX while searching is very important because You want to give ease of access. You want to make the search results return very quick. By the way, in the examples that in the demo that we've shown, we are using Redis also as a primary data store. That does help. But obviously, in the overall user experience, that's one thing that I would suggest to you guys is give it a try. I know everybody's using it as a cache. Caching is okay. You can use memcache for that. But if you want a primary data store, Redis can work for that. And full-text search is not always a solution, even though we started with that idea. But again, Redis and RediSearch make search easy and fast. That was it. I didn't take too much of your time. Have you got any questions for me?
Questions?
A question?
If you had to build in a capability like spell check or something, how would that fit into this model?
Okay. It's an easy question, isn't it? Well, I think I would. You need to ingest your spell checker. Well, I think you could use something like this, but I don't think it would be 100% the accurate way to do it. So what happens is this: you need to ingest the whole English or whatever language dictionary into your Redis tree. Okay. Then you can do a query by autocomplete, but the thing is, people can make a mistake even as on the first letter. Okay, so if you look at the module, the Redis module allows you to do fuzzy queries. Fuzzy queries are queries where there's a fancy name for it, but it will return strings that have a distance of 1 from your string, which means that they differ at most by 1 character. Okay, so it kind of helps you a little bit, but yeah, you're not asking me an easy question because it's definitely built around this. But you would, in order to do, you would have to extend the current module to allow you for a level of fuzziness greater than that, so multiple characters not matching, and then you will have to enhance it by commonality of a word, okay? Because you can have multiple options, but you want to show them by the most common to the least common as well. So yes, yeah, that's what I would do. No other question? Cool.
Thank you.
All right. Thank you, guys. Cheers.